Okay, so we define theoretical as what in theory should happen. Experimental is what happens if I actually did it. So if you look at example 1, the graph shows the results. Okay, this is the graph. That's the experimental part. Shows the results of an experiment in which a number cube was rolled 100 times. Determine the experimental probability of rolling a number 3 for this experiment. Then compare it to the theoretical probability. Okay, well, they actually rolled a 3 16 times. So it is 16 out of 100. Can I reduce that? Yes, it's divisible by 4. So I could get 4 25ths. Okay? Now, I want to talk about this for a second because we haven't been talking about percentages a ton. But if I were to give this a percentage, it would be 16%. Does that make sense? That's a way to easily compare it. Okay? So the theoretical probability, so the experimental probability of rolling a 3 is 4 out of 25. You good with that so far? Okay? Which is close to the theoretical probability of 1/6. 1/6 is the theoretical. If I rolled the dice, what would be my probability of rolling a 3? 1 out of 6, right? Okay? If I were to turn 1/6 into a percentage, it would be 16.6 repeating percent. Is that pretty close to the actual percentage? Yeah, it's pretty close right there. It's like a less than a percentage point off. So that it looks like it's a pretty true between theoretical and experimental. Yes? Okay? Now, look at example 2. In a telephone poll, 225 were asked whom they plan to vote for in the race for mayor. What is the experimental probability of Juarez getting a vote from a person selected at random? Okay, well, out of 225, Juarez got 75. So the experimental probability would be 75 out of 225, which if you reduce would be 3, or actually we're going to go 1/3. Because they would reduce to 3 ninths and then you could go 3 ninths because you could divide by 25, but then that would go on to 1/3, which divide by 75, 225 divided by 75 is 3. Okay, so the experimental probability is 1/3. If I would have done the theoretical probability, I would have said he had a 1 in 3 chance because there's 3 people running. He's 1 out of the 3, right? So is it pretty close? Yes. Now here's where we're going to get into applying this. We're going to apply it to proportions. So we're going to say, suppose 5,700 people vote in the election. How many can be expected to vote for Juarez? Well, if 1/3 of the population votes for Juarez, because that's what voted in the first part, right? Then how many out of 5,700? So 1 out of 3 vote for him. How many out of 5,700? We've seen that before, right? Can we solve that? Yeah. So 3 times x, 5,700 times 1. 3x equals 5,700. 5,700 divided by 3 is going to equal 1,900. So out of 5,700 people, Juarez can expect about 1,900 people to vote for him. This is how they do elections. That's how they get a percentage of they take a sampling of people and then they apply it to the whole population. Does that make sense? So when they're saying, oh, this person leads by, he has a 67% chance of winning, well, they took a sample and then applied it to the entire population. That's what they do. Okay, so use the graph. Okay, we're down one more exercise. Are we ready? Use the graph of the survey of 150 students asking whether they prefer cats or dogs. Okay, I don't know if I deleted it or what, but this is cats and this is dogs. I mean, because of course everybody likes dogs more than cats.
No, not even close.
Okay. Okay, so what is the experimental probability of a student preferring dogs? Well, the experimental is 132 out of 150. Because there's 132 people that liked it out of 150 surveyed. So we're going to have to simplify that, okay? So you can divide by 2. So I would get 132 divided by 2, 6. So 66 out of 75, and then you could go by 3. I think you could have done it by 6 earlier. Okay, so if you divide it by 3 here, you would get 22 out of 25. Okay, so you should have got 22 out of 25 prefer dogs. Okay, now, okay, suppose 100 students were surveyed. How many can be expected to prefer dogs? Okay, well, dogs were 132 out of 150. So what if we went down to 100? What would that scale down to? Okay, so we would set that up as a proportion, and we would cross multiply and divide, and we would get our answer. So we would say 150x, and I'm out of room, so I'm going to go over here, equals 13,200. And I'm going to divide 13,200 divided by 150. And I'm going to go 8. It's going to go in there 8 again.
Miss Hawkins, couldn't you have just used the one from the other one and times it by 4?
Yeah, I could have scaled it up, yeah.
Okay, that's enough.
I was just trying to set it up in consistent manner. So yes, that would work. I could have used this and scaled up times 4 and gone 100 that way. So that works. That's awesome that you see that. I'm glad. Okay, I was just trying to go in a consistent what you would do. Okay, so suppose 300 students. Well, if 80, okay, so how many can be expected to prefer cats? Well, if cats is 18 out of 150, how many out of 300 we would what? Double it. So it would be 36 would prefer cats. Okay? So not too bad so far, right? Okay. So look at this. This is where we start having to flip back and forth, and I really need you to stay with me, okay? So it says the table shows the results of a fair number cube rolled 40 times. So these are the results from a number cube rolled 40 times. Determine the experimental probability of rolling a 4. So the experimental probability is 8 out of 40, which reduces to 1/5. So that's it. Not too bad, okay? But then they say determine the theoretical probability of not rolling a 4. So not 4 is 1, 2, 3, 5, and 6. So that's 5 out of... No, theoretical. Theoretical means what in theory. Remember, we're back to theoretical. This was experimental. This is theoretical.
Was the answer 5?
Okay, so now determine the theoretical of rolling a 2. Well, that is 1/6. Determine the experimental probability of not rolling a 6. So that would be everything else except a 6. So that's all this, which is 36 out of 40. So if we divide by 9, divide by 4. Divide by 4, we get 9/10. And then suppose the number cube was rolled 500 times. Based on the results in the table, about how many times would you land on a 5? Well, we landed on a 5, 12 out of 40. So how many out of 500? Now, you could scale down 12 out of 40. You could simplify that, or you could just 40 times x. 500 times 12, divide by 40. So that's probably what I do. Or I could simplify 12/40ths, and it would be 6/20ths, 3/10. If I simplified it, because this would simplify to that, right? Okay, so, and then I could scale up. This would be times 50. And what would I get? Or I could cross multiply these and do it the normal way, and either way would work. Okay, either way works. So you can cross multiply and divide if you feel comfortable. If you want to scale it down, I could scale it down, and then I could see how to scale up from there. But you got to do what works with you. Okay, anybody have any questions? We need to go right here. Okay, so the main part is that we need to understand experimental is they give you the information somewhere. Theoretical is what we've been doing. What should happen if I roll a number cube? It should be 1 out of 6. What should happen if I flip a coin? Okay, but I've got to watch the wording go back and forth between the questions, because that's what's going to try to confuse you with. Okay,